Good morning, everyone. Our today's discussion is on electromagnetic fields and waves. Before discussing deep into the syllabus, let us understand the concept of field. Actually, what is field? Field is a terminology that refers to a region in space where physical quantity like force, energy, potential is assigned a value at every point. This field helps to describe how objects influence their surroundings even without direct contact. There are many types of fields: scalar field, vector field, and tensor field. Scalar field is the one where each point in space has single scalar value. For example, if we measure the temperature of this room, it gives some value in terms of Celsius or Kelvin. Each and every point in this room will have some temperature value. Next is vector field, a field where each point in space has both magnitude and also direction. For example, if we consider wind blowing in a particular place, maybe with different directions. The velocity of the wind also varies, depends upon the place where it is measured. Next is tensor field, a more complex field used in physics. For example, stress fields in materials, gravitational fields in general relativity. So, our today's topic is about electromagnetic field. What an electromagnetic field is? It is the combination of electric and magnetic fields that interact with charged particles. This is produced by interaction of time-varying electric and magnetic field. Electric field is designated as E. This is produced by stationary charges measured in volts per meter, whereas magnetic field B, it is generated by moving charges measured in Teslas. These fields can propagate as electromagnetic waves like radio waves, light waves, X-rays, gamma rays, and so on. This voltage produces electric field. Time varying electric field produces magnetic field. Magnetic field is a maybe stationary or time varying, depends upon the time varying current. When the current is varying with respect to time, then the magnetic field will also vary with respect to time. So, time varying magnetic field produces electric field. For example, transformer is the best example. This flux varying with respect to time produces EMF. So, some other examples of fields is gravitational field, electrostatic field, and magnetic field. Gravitational field is a field that represents the force of gravity acting on an object. For example, Earth's gravitational field pulls objects downwards. Whereas electrostatic field, the field around charged particles that exerts force on other charges. For example, force between two charged spheres or two charged particles. Magnetic field, the field created by moving charges or magnetic materials. That is, the best example for magnetic field is the field that exerts around a magnet or a current carrying wire. Major difference between circuit theory and field theory. So, circuit theory deals with voltage and current, whereas the field theory deals with the electric field and magnetic field. Circuit theory, only the two parameters are considered, voltage and current. Those are scalar quantities, whereas in field theory, electric field and magnetic field are the important parameters, and those two fields are vector quantity. Radiation and effect are neglected. Here the radiation effect is considered in the field theory. It's useful only in low frequencies whereas the field theory, it is independent of frequency. Next topic is static electric field. Static, it simply means which is stationary. The constant fields which do not change with respect to time or intensity or direction, in contrast to low and high frequency alternating fields. Static magnetic field is created by a magnet or charges that move as a steady flow. It is otherwise called as magnetostatics. Electromagnetic field, it is a property of space caused by the motion of electric charges. A stationary charge will produce only an electric field in the surrounding spaces. If the charge is moving, a magnetic field is also produced. We all know the moving element creates magnetic field. An electric field can be produced also by changing magnetic field. The mutual interaction of electric field and magnetic field produces an electromagnetic field. The major applications of electromagnetic field is microwave, analysis of antennas, electric machine transformers, analysis of power system, electromechanical energy conversion, wireless communication engineering, optical fiber. So the applications are not limited. It also extends in major areas of the medical field. So hope you all understood this session. This is simply an introductory session. We'll discuss further in the next class. Thank you. Thank you for listening.